It's just after 2:24 a.m. Pacific Daylight Time, or 9:24 Coordinated Universal Time on Friday, June 29th, and you're looking at a live shot of Space Launch Complex 40, where the SpaceX Falcon 9 rocket is about to launch our Dragon spacecraft carrying more than 5,900 pounds of cargo to the International Space Station. My name is Michael Hammersley. I'm a materials engineer in our avionics department here at SpaceX headquarters in Hawthorne, California. And I'm thrilled to be here with you to cover our 15th cargo resupply mission to the International Space Station, also called ISS. We're at T-minus 18 minutes and counting, and all systems are currently go at Cape Canaveral. This will be SpaceX's 12th launch of 2018 and the third NASA CRS mission to use both a flight-proven rocket and a flight-proven spacecraft. CRS-15 will also mark SpaceX's 9th flight-proven booster to fly this year and the 14th to date. That means SpaceX has actually flown more flight-proven rockets this year than new vehicles, and we expect that trend to continue into the future. Falcon 9's first stage for this mission previously supported the TESS mission in April of this year, which at 2 and a bit months makes it the quickest turnaround time for a flight-proven booster so far. CRS-15's Dragon spacecraft previously supported the CRS-9 mission in July of 2016. Both Falcon 9 and Dragon were designed with reflight in mind, so the vehicle hardware is built to support multiple missions with minimal refurbishment in between. For this mission, we've refurbished Dragon's heat shield and thermal protection system on Dragon's exterior. We also replaced the passive common berthing mechanism, which is the ring on top of Dragon that connects to the ISS. So you'll notice that Dragon, as you can see there, looks very clean, in distinction to the Falcon 9 first stage, which has not been scrubbed down. And you can still see the soot from re-entry on that. Yes, there's the soot that you can see there. That said, SpaceX does not plan to recover the first stage for this mission. You'll also notice that there are no grid fins, nor are there any landing legs, though I guess they're a bit obscured by the gaseous oxygen being vented there. We also don't have a drone ship in the Atlantic Ocean. So while SpaceX will not follow the first stage during its re-entry, we will have coverage of the Dragon spacecraft all the way through its solar panel deploy. Let's check in on the status of Falcon 9 and Dragon. Final cargo was loaded into Dragon about 24 hours ago, and the vehicle was raised about 8 hours ago. Pad was cleared at T-minus 6 hours, and the key takeaway for the moment is that we are tracking no issues, and we are on track for an on-time launch, just under 15 minutes from now. Today's launch window is instantaneous, which means we have only 1 second in which to launch Dragon. So that means that if we scrub today's launch or have an abort for any reason, we have to move to our backup launch date, which is July 1st at 4:54 a.m. Eastern Time. The go, no-go poll was conducted just over an hour ago, and propellant loading began shortly thereafter at T-minus 70 minutes. As you may recall, to make fire you need 3 elements: fuel, oxygen, and an ignition source. So for Falcon 9, our fuel is RP1, which stands for Rocket Propellant 1. It's a grade of kerosene that we're using. And our oxidizer is densified liquid oxygen. The first stage is currently at about 99% full of kerosene and about 80% full of liquid oxygen. The second stage is currently also at about 99% RP1 and only at about 20% of liquid oxygen at the moment. But we should be all full by about T-minus 5 minutes for RP1 and T-minus 3 minutes for liquid oxygen. We like to keep that loaded as close to liftoff as possible in order to keep it as cold as possible to fit as much onto the vehicle and have as much thrust as possible. Which leaves the third part of the fire triangle, our ignition source. What we use is a chemical mixture called TTEB, which stands for triethyl aluminum and triethyl borane. It's quite a mouthful, but what's special about those two chemicals is that they burn on contact with each other. They also burn a bright green. So look for a green flash near the engines right at launch, and that's what ignites the RP1 and liquid oxygen to provide the main power for the rocket. Final helium loading is also underway. We use helium to keep the tanks pressurized when we're emptying it of propellant during ascent. And Dragon is also getting ready. It began its auto sequence at T-minus 35 minutes. That's when it coordinates timing with Falcon 9 and makes sure its systems are all healthy. The next big step for Dragon is to move to internal power at T-minus 8 minutes, which is coming up only a few minutes from now. The range is also ready to support, and we're currently looking at 90% favorable weather for launch, which is great for being so close. There's a slight weather concern of lingering cumulus or anvil clouds, so we are keeping an eye on that. We've also been launching balloons every 30 minutes or so to check on the wind speeds at various altitudes. Upper level winds are looking light, with max speeds from the west at 20 knots near 37,000 feet. We generally want those winds to be all under about 30 miles an hour. We also make sure there isn't too much wind shear, which is when winds at different altitudes are moving in different directions, which makes it a bit tricky to move through them. Overall, we continue to be go from Space Launch Complex 40 at Cape Canaveral Air Force Station to launch exactly 11 minutes from now. Our Dragon spacecraft has been flying for 6 years now, and it was only a design on a piece of paper in 2007. Today, it's the only vehicle flying that can deliver significant cargo both to and from the International Space Station, and it's been an exciting ride to get to where we are today. And you can see on your screen at the moment, we're venting some gaseous oxygen, so no worries there. In 2010, SpaceX became the first private company to send a spacecraft to orbit and return it to Earth. 2 years later, in 2012, Dragon became the first privately developed spacecraft to visit the International Space Station. And since then, we've made a total of 13 trips to the ISS, and we're under contract with NASA for a total of 26 cargo resupply missions. And while we're currently flying only cargo missions, we'll soon also fly humans to space as part of NASA's Commercial Crew Program. SpaceX is upgrading its Dragon spacecraft to support human spaceflight, with its first demonstration mission targeted for later this year. In fact, SpaceX recently completed its 16th test of Crew Dragon's parachute system at the Naval Air Facility El Centro in Southern California, which verifies the system's ability to slow Crew Dragon and ensure a safe landing in the unlikely event of a low-altitude abort. And there, it's a soft touchdown. That's just one of the several hardware milestones we've completed in partnership with NASA as we prepare for our first crew missions. Dragon is packed with more than 5,900 pounds of research, cargo, and supplies headed for the International Space Station and its 6 crew members. That includes dozens of research payloads to the International Space Station, including research from the National Laboratory, operated by the Center for the Advancement of Science in Space, or CASIS. Let's take a look at some of the groundbreaking research from CASIS that will be aboard the CRS-15 mission.
5, 4, 3, 2, 1.
This launch represents the 15th resupply mission by SpaceX to the International Space Station. This mission is truly packed with an incredible amount of research that has the capacity to benefit life on Earth. Let's find out a little bit more about some of the payloads that are destined to the space station on this mission, sponsored by the U.S. National Laboratory. AngieX is an innovative startup based in Cambridge, Massachusetts, looking to improve cancer patient care. AngieX has created a novel cancer therapy targeting a protein in the proliferation of endothelial cells, which line the walls of blood vessels. This project seeks to evaluate if these cells, cultured in microgravity, represent a valid system to test the effects of vascular-targeted cancer drugs on normal blood vessels. The University of Florida has a rich history in plant biology research. Now, a new University of Florida plant biology investigation seeks to develop electrochemical cells suitable for spaceflight to study instability under microgravity conditions. The investigation could ultimately develop algae that could help sustain both a low Earth orbit space economy and long-duration deep space missions. The University of California, Santa Barbara, in association with the National Science Foundation, is sending a project focused on the study of forces between particles that cluster together. In microgravity, investigators can observe how particles cluster over long time scales without gravitational settling, which complicates measurements taken on Earth. This work has several important applications that will benefit life on Earth, including ecosystem modeling, deep water hydrocarbon exploration, sequestration, and mobilization of contaminants, among others. There are multiple student organizations supporting education investigations intended to stimulate and engage the next generation on this mission. One such group is the Student Spaceflight Experiments Program, in partnership with DreamUp and hardware developer Nanoracks. This collection of students around the world will send over 30 separate student investigations on this mission. This is just a small portion of the incredible amount of research that is destined for the space station as part of this mission. To learn more about all the payloads on this mission, or to learn how to become part of the space station research community, visit iss-cases.org.
So yeah, that's just a few of the literally dozens of research experiments that Dragon's going to be taking up to the space station. You can also follow at ISS_research on Twitter for more information about the important microgravity research happening at the International Space Station. Along with bringing research, Dragon's unpressurized trunk is carrying a new Canadian-built latching end effector, or LEE for short. This new LEE is being launched as a spare to replace the unit astronauts removed during a series of spacewalks in the fall of 2017. So each end of the Canadarm2 robotic arm has an identical LEE, and those are used as the hands that grapple payloads and visiting cargo spacecraft. So if you can imagine sort of a pen being the arm, it's got one that reaches out and another that's attached to ISS. And what's cool is that having it on either side enables Canadarm to walk, rather like an inchworm, to different locations on the orbiting outpost, including Canada's mobile base, which travels along rails on the space station's main truss. We're now just past T-minus 4 minutes and 30 seconds, and that means Falcon 9 is stepping into the final phases of terminal count. In these last few minutes, Falcon 9 is performing final checkouts to make sure all primary systems are working in flight. Those checkouts include the communication systems and the avionics systems, which are all looking nominal. Engine chill began a few minutes ago at T-minus 7 minutes. That gets the engines cold enough to safely move propellant, which is all a couple hundred degrees below zero, without causing it to accidentally boil upon that initial contact. Next checkouts are the thrust vector control checkouts at T-minus 3 minutes. We wiggle the engines to make sure they'll be able to properly steer Falcon 9 during ascent at that point. And at T-minus 1 minute, Falcon 9 will enter startup mode. The rocket is then in control of the remainder of the countdown. Dragon's also performing its own final checkouts to make sure all of its primary systems will work in flight over the 3 days it's going to take to rendezvous with the space station. And just before liftoff, watch to see the strong back retract. The strong back, or the transporter erector, is the frame that you see standing up right just next to Falcon 9 on the left there. And it retracting gives Falcon 9 a bit more clearance during launch. Overall, range is a go. Weather-wise, everything's looking good. So at this point, let's listen in to the last couple minutes of terminal count.
Stage 1 locks to close out for flight. Stage 2 locks to close out for flight. Gas closeuts have started. Vehicles in startup.
Go for launch.
Gas closeouts complete. Stage 1 tanks press on for flight.
T-minus 15 seconds. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Ignition, liftoff.
Stage 1 prop is nominal.
Vehicles pitching downrange.
Power and telemetry nominal.
And there you saw we had a successful liftoff of the Falcon 9. If you were watching closely, you also saw the strong back retract just during that initial part. We're currently throttling down the main engines in order to minimize some of the pressure as we move through supersonic, and coming up next, max Q. which is the point of maximum aerodynamic pressure, where the rocket's pushing hardest against the
Vehicle is
atmosphere.
supersonic.
And then we just had a call out the vehicle's supersonic. Max Q coming up shortly. That's when the rocket's moving very quickly and hasn't quite gotten out of the atmosphere yet, so it's getting a lot of pressure.
Vehicle has reached maximum dynamic pressure.
And there it's made it through that milestone, which is a major part of every rocket launch. Coming up about 45 seconds from now, we'll have a few events in quick succession. The main engines will cut off, the two stages will separate, and the second stage will ignite.
MVAC engine chill.
The call out for MVAC engine chill means that just like the first stage engines, the second stage engine is also being cooled down to be ready for moving all that super cold propellant through it. That main engine cutoff event coming up not too long from now.
MECO.
Stage separation confirmed.
And there you saw it. The main engine's cut off,
MVAC ignition.
the two stages separated, and MVAC
Stage 1 AFTS is safe.
burning really bright has begun. The second stage is now carrying Dragon towards low Earth orbit. Again, we are not following the first stage.
Vehicle is on a nominal trajectory.
We're not recovering this one. In fact, it's the last Block 4 vehicle as we transition to Block 5.
Review the acquisition of signal.
We're now at T plus 4 minutes. The Merlin vacuum engine is looking great, and we are on a nominal trajectory towards that initial low Earth orbit. The second stage is going to drop Dragon off in that low Earth orbit, and Dragon will be raising itself over the next 3 days to connect or to rendezvous with the International Space Station. It'll be there for about a month, and then it will also be bringing back the that latching end effector, which is the hand of Canadarm. It'll be bringing back the old one when it returns.
Position at New Hampshire.
You'll also notice that there's a lot more detail that you can see on the Merlin vacuum engine. It's actually flying into daylight right now, which is why some of that detail is more visible. We're at T plus 5.5 minutes. Merlin vacuum engine still performing nominally, headed on the right trajectory to get to low Earth orbit. Has about 3 minutes remaining in this burn. It's an interesting semantic point that the process of connecting Dragon to the International Space Station is called berthing with an E because it is brought into the station by Canadarm. while docking refers specifically to two spacecraft that connect without any external assistance. This stems from the old shipping days in which small ships would come into harbor and dock themselves under their own power. But larger ships, which aren't able to navigate as easily in harbors, are met by tugboats and then berthed. So for the International Space Station, that robotic Canadarm is like a tugboat, and so Dragon is also berthed.
Vehicle remains on a nominal trajectory.
We're just coming up on T plus 7 minutes. The vehicle's still on a nominal trajectory towards low Earth orbit. And Merlin vacuum engine still performing great. We've got about a minute and 10 seconds left in this second stage burn. We're at T plus 8 minutes.
Stage 2 is in terminal guidance.
The second stage is
Stage
starting
2
to
AFD
throttle the
assist.
NVAC D engine in order to prepare for shutdown. That shutdown event coming up only a few seconds from now.
MECO.
And there you can see the second stage engine has shut down.
Nominal orbit insertion. Acquisition of signal.
And we've also just gotten confirmation that the orbit that the second stage and Dragon are in is a nominal orbit. So at the moment, both Dragon and the second stage are coasting. And Dragon is shortly going to deploy from the second stage. That's when the second stage is going to release Dragon so that it can carry itself to the International Space Station over the next couple of days. 3 days, to be specific.
Payload deploy confirmed.
This is CC on countdown, Dragon from
And there
separation.
you see it. Dragon has successfully deployed. We've got a number of important steps still coming up. The solar array is going to deploy next. The solar arrays power Dragon during its rendezvous process with the International Space Station. That process itself consists of several engine burns. Those are height adjustment and co-elliptic burns. And those adjust the orbits to get it closer to the International Space Station and then to finally get reached out to by the Canadarm. So during the last about 30 kilometers or so, where Dragon and ISS are close enough, they'll establish a direct communications link. And then Dragon will slowly approach, pause at several checkpoints along the way to ensure everything is still going as expected. And eventually, in the early hours of Monday morning, Pacific time, Dragon will be close enough for the Canadarm to grab it. Those solar arrays will be deploying just under a minute from now. We're hoping to be able to...
This is Dragon CC on countdown.
bring
Dragon's
you video
propulsion
of
system
that.
has successfully primed and all thrusters report ready for firing.
Deploy coming up just a couple seconds from now.
Dragon is deploying its solar arrays.
And there you can see those solar arrays are slowly unfolding in order to be generating power for Dragon over the next 3 days. It's actually the backside of the solar arrays that you can see at the moment. It's the front sides, of course, which will actually be generating that power. And another view of those solar arrays. Looking great, just coasting there above the Earth in the background.
Lots of signal in New Hampshire.
So at this point, Dragon is coasting on its way to the International Space Station. Its mission isn't over yet. It's going to be spending the next couple days,
Dragon solar arrays
3 days
have
again,
successfully
approaching
deployed.
the International Space Station, arriving on Monday, July 2nd, in the early hours of the morning Pacific time. It's going to spend about 1 month at the space station, and the arrival of Dragon to the space station and the grapple, where Canadarm actually reaches out to grab it, will be streamed live on NASA TV starting at about 5:30 a.m. Eastern Time. So again, we had a successful on-time launch of Falcon 9. The 2 stages separated. The second stage took Dragon into low Earth orbit, and Dragon is now on its way. So thanks
Dragon solar
to
arrays are ready for
NASA,
activation.
the range, and the FAA for supporting us in today's mission, and thanks to you, the viewer, for joining us and watching it. If you'd like to join us here at SpaceX as a career, please check us out at spacex.com/careers. Otherwise, look for further updates on our social media accounts, and we'll see you next time.